So what we are going to learn is called area of a region between the two curves. So area of a region between two curves. So let's say I have two functions. This is x, y. Let's say I have two functions. Let's say this is f of x, and there is another function g of x. And I have to find the area between A and B, between the curves, not under any curve. The area that's sandwiched between the curve, which means I'm talking about this bit under the curve, between the curves. So it's very, very simple. Now, in this scenario, f of x, which is the y value, is obviously this point is greater than this point, right? So can I say f of x is greater than g of x? If I look at point number A is this value of g of x, whereas it is this value of f of x. So, so this value, f of x is greater than g of x, because this point is greater than this point. And similarly here as well, almost the f of x is greater than g of x. So in both a and b, for both a and b, f of x is greater than g of x. Now, the easy eyeball check is when there are curves which are lying one on top of the other, the curve that sits on top is greater than the curve that sits at the bottom. Very, very simple eyeball check. In this scenario, that's the case. So the definite integral tells me that area for this region, the yellow region, between A to B is f of x take away g of x dx. As simple as that. Where f of x is greater than g of x, right? Or I can then say f of x, I can then apply the integral rule of, I can split the integral that I can find. It's very, very simple. Right? Now, if I have a curve like this now, let's say I have the other curve could be so let's say this is f of x, this is g of x. And I have to find the area between the curves. So let us say I'll just make some more space here. Let's say that's the point that I need. I need for the points A, and then I need for the points C1, then C2, then C3, and then maybe C4, and let's say another point here, B. So I need to calculate the area which is all of that. All of that. Right? So that's what the goal is. Okay. So now let's look at the first region, this region, from A to C1. When I said that one sits on top of the other, f of x is sitting over g of x. So my area for this region is going to be f of x, take away g of x between A to C, C1. Let's talk about this area. Now red curve sits above the blue curve. So red curve, g of x, take away f of x between C1 and C2. Obviously dx, C1 and C2. Let's look at this. Now blue curve sits over the red curve. So f of x minus g of x, C2 to C3, dx. Let's look at this one. The red sits on top of blue. So from C3 to C4, g of x take away f of x. And the last one, the blue sits on top of red. So f of x take away g of x dx from C4 to B. And then you add all of them up. So add all of them up. You add all of them up and you get the area between the region. You know, sandwich between the area of the region, sandwich between two curves. Very, very simple, right? Now, if you have a curve like this, let's say y equals to x cube, or f of x is x cube, which means you've got a curve like this. And another line is, let's say y equals to 2x, or let's say g of x equals to x. So which means a straight line. Now, if I'm asked to find the area between these two curves, how will I find it? This is x, this is y. I have to find this point and this point first. And I know that's another point. So I need to, for this area, I need to find x1, and I know this is 0. And this I need to find the x2. So I need to find from x1 to 0. Now, if I just look at this portion, who's sitting on top? The blue line, which means the cubic minus the linear, dx. And for here, I now have the linear sitting on top of the cubic. So I'll have from 0 to x2, x minus x cubed dx. And I add them. But the challenge is, how do I find x1 and x2? They are nothing but point of intersection between two curves. So how do I find the point of intersection? I just equate them. So if I equate them, what do I get? I get x cubed minus x equals to 0, and I get x square minus 1 equals to 0. X equals to 0, I already have that, and x equals to plus minus 1. So this point is actually minus 1, and this one is plus 1. So I will replace this by minus 1, and replace all these. I will replace this by plus 1. And I add the two. So this is, in a very, very simplistic manner, how do you find the area between the curves?